Post-attack forensics, traffic pattern analysis. Traffic pattern analysis can help network administrator to develop new filtering techniques for preventing attack traffic from entering or leaving their networks. The output of traffic pattern analysis helps in updating load balancing and throttling, throttling. Packet traceback. Packet traceback is similar to reverse engineering. It helps in identifying the true source of attack and taking necessary steps to block further attacks. Event log analysis. Event log analysis helps in identifying the source of DOS traffic. Providers can use honeypots and other network security mechanisms such as firewalls, packet sniffers, and server logs to store all the events that occur during the setup and execution of the attack. This allows network administrators to recognize the type of DDoS attack or a combination of attacks used. Zombie Zapper tool. When the network IDS notices the high volume of traffic, the target victim can run Zombie Zapper to stop packets from flooding the system. Techniques to defend against botnets. There are four techniques to defend against botnets. RFC 3704 filtering. It is designed to limit the impact of distributed denial of service attacks. It does this by blocking traffic with spoofed addresses which access to the network. It also helps to trace the traffic to its correct source. A bogon list consists of all unused or reserved IP addresses that should not come from the internet. If a packet is sourced from any of the IP address from the bogon list, then it should be filtered. Usually, this RFC 3703 filtering is done by ISP. System administrators should check for this filtering at ISP. If not, the system administrator must manage their own bogon ACL access control list rules or switch to another ISP. Next is Cisco IPS source IP reputation filtering. Reputation filtering. Here, IPS is intrusion prevention system. Latest Cisco IPS is IPS 7.0. Reputation services help in determining whether an IP or service is a source of threat. Cisco IPS 7.0 consists of security capability called as Cisco Global Correlation. It contains information about all known threats on the internet, such as botnets, malware outbreak, darknets, and botnet harvesters. Makes use of this network to filter DOS traffic before it damages critical assets. Next one, black hole filtering. Black hole filtering is a common technique to defend against botnets and thus to prevent DOS attacks. Black holes refer to network nodes where an incoming traffic is discarded or dropped without informing the source that the data did not reach the intended recipient. Undesirable traffic can be dropped before it enters a protected network with a technique called remotely triggered black hole RTBH filtering. Uh, As this is a remotely triggered process, this filtering must be performed in conjunction with ISP. DDoS prevention offering from ISP or DDoS service. This method is effective in preventing IP spoofing at the ISP level. Here, the ISP scrubs cleans traffic before allowing it to enter a user's internet link. Because this service runs in the cloud, DDoS attacks do not saturate the internet links. In addition, some third parties offer cloud DDoS prevention services. IP source guard in Cisco or similar features can be enabled in other routers to filter traffic based on the DHCP snooping binding database or IP source bindings, which prevents bots from sending spoofed IP packets. DDoS protection at ISP level. One of the best way to defend against DDoS attacks is to block them at the gateway. This task is performed by contracted ISP. ISP offers a clean pipes service level agreement that provides an assured bandwidth of genuine traffic rather than the total bandwidth of all traffic. Most ISPs simply block all requests during a DDoS attack, denying even legitimate traffic from accessing the service. Enabling TCP intercept on Cisco iOS software. As we saw earlier, the TCP intercept feature implements software to protect TCP servers from TCP SYN flooding attack. This is done to protect the TCP servers from SYN flooding attacks. We will see how to configure the TCP intercept on the PuTTY command console. So first, as we know, first is to enter the command enable, and then we have to give this command configure terminal, and then access list number, deny or permit, host IP address, or any or host. So example, access list 20, permit any. So the access list number 20 will have a list of IP addresses that will be permitted. Then IP TCP intercept list access list number. Fifth command is IP TCP intercept mode, intercept or watch. So in intercept mode, the router intercepts the SYN packet and sends SYNAC on behalf of server. If there is no response to SYNAC, then it sends to the server. If there is a response to SYNAC, then it sends to the server. In wait mode, it allows the SYN packet to the server and wait for connection to establish. If there is no connection established within 30 seconds, the router sends a reset request to server to close the connection. So DDoS protection tools. Next module. This is the last module. Some of the examples are given here. 40 DDoS 1200B terabyte DDoS protection system DPS, DDoS protector, A10 Thunder TPS, Imperva encapsula DDoS protection, anti DDoS guardian. This is discussed in iLabs. DDoS protection services, Akamai DDoS protection. Remember GitHub use this Akamai to divert the traffic when a DDoS attack was performed on the GitHub. So that's it about the denial of service module. Maybe we will look at some of the lab exercises in the next coming videos.